right, go. Hello again, everybody. I'm back again with my handy dandy fanny. Today we're going to go into tangential motion. It's still circular motion, but we're worried about the tangent line as opposed to the whole rotation itself. But before we get started, review. You have angular displacement is the arc length over the radius. To convert, you have to take your angular degrees and multiply by pi over 180. That's going to give you the amount of radians. Your angular velocity is given by this equation. Your angular acceleration is given by this equation. The units for angular velocity is radians per second, and for angular acceleration is radians per second squared. Just as if this was a linear thing, your velocity here would be better if you had a marker that worked. Your velocity here would be your distance over time. Your acceleration here is your change of velocity divided by time. So here's the translation from angular to linear. That's all we are doing. All of the equations are going to be the same, but you're gonna substitute the angular variables as opposed to the linear variables. Now, something that we have to note, anywhere on the rotation of the circle, on the radius, for a rigid object that is spinning, you always have the same angular velocity and angular acceleration as it spins, okay? When you're talking about tangentials, you're going to have different tangential velocities and acceleration depending on where it is on the radius of that object spinning. So we have the same angular acceleration and velocity as it spins, but because of the radius changing, that gives you a different velocity and acceleration for the tangential values. If we're okay with that, we're going to trade boards and then we'll be back in 1 minute. Okay, everybody, we're doing new stuff today now. Tangential values. We're going to be talking about tangential velocity and tangential acceleration and centripetal acceleration. So, first thing we have to do is understand what a tangent is. A tangent, if you remember in trigonometry, is a line that is perpendicular to the radius of a circle that only hits that circle at one particular point. So, a tangent is perpendicular to the radius of the circle, and it hits the circle at one particular point as it crosses. When you're looking at tangential velocities and acceleration, if you have a ball on a string, for example, and this is the radius of the string, and this is rotating in that direction, your tangential velocity is always at 90 degrees to the radius of the circle, and I'm going to call that V sub t, the tangential velocity. Now, as it continues to spin around, that obviously is going to change the direction of that velocity. So you have an initial tangential and you have a final tangential velocity as the thing rotates. That is the same as the acceleration. If the thing continues to spin, you also have a tangential acceleration for that object that's going around. Now, anytime an object goes around in a circle, I'm just going to be drawing a lot of circles today. The reason why this thing continues to follow the circular path is because there is an acceleration going towards the center. That is called centripetal acceleration. Centra means center, pedal means towards. I think we have discussed this before when we discussed friction. as you are going around in a vehicle and you take a turn, the reason why that car follows that turn is because your frictional force is the centripetal acceleration. I should say the friction causes the centripetal acceleration. The frictional force is the centripetal force, which we will discuss later. So for tangential values, tangential velocity is going to still equal a distance over time, but because you're talking about circles, your distance is going to be 2 pi r. If you don't know what that means, that is the circumference of the circle itself. So it is the distance all the way, holy jeez, that's a horrible circle. It's the distance all the way around the circle if something is rotating on the circle, and then the time is going to be the period that it takes to complete one cycle. That is what period is. This fancy T is known as period in physics. So it's still a distance over time, but you are using the circumference of the circle divided by how long it takes to complete one true cycle. So that's how you get the tangential velocity, and then your tangential acceleration, right? We should say the centripetal acceleration is going to be your tangential velocity squared divided by the radius of the circle itself. If we were to convert this into rotational equations, that is r Wumbo squared. But we're not going to worry too much about that rotational stuff. We're going to worry about tangential stuff. Your rotation for the tangential is Wumbo times radius. But we're going to mainly focus on this stuff right here. Okay, so one of the most often questions asked when we're talking about circular motion is why, when you're traveling in a circle, why does the acceleration always go in towards the center? And this is a fairly easy thing to see here. So if you are rotating in this direction, you have an initial velocity going in that direction, and you pick any other point of that object as the final velocity. All you have to do is take the initial velocity vector and the final velocity vector, take the difference of the two. You should be aware the difference is going to be Vf minus Vi. But again, we're talking about vectors. So you have to actually take the vectors itself, take this vector, put it over here, that is your Vf going down that direction. Your initial vector going this direction is being subtracted. Minus sign in physics just means opposite direction. So if you take this and flip it, and now this is going in that direction, well, guess what? Once you take the sum of these two vectors, that resultant vector, if I can find a pen that works, that resultant vector actually goes into that circle. So if you take this, to split the difference, you take this vector there, that is the difference of the two vectors. And again, this is the same thing as taking the change of velocity. Change of velocity is an acceleration. Your centripetal acceleration is always towards the center. And you can do this with any 2 points on the circle. Say we take this point as your Vi, and you take this point as your Vf, and we do the vector doodad thing again. This vector is going up this way. This is a negative vector, so it's going to go back this way. So therefore, your resultant vector of the acceleration is going to go in that direction. So these 2 points added together goes in towards the center. Pretty cool if you ask me, but nobody ever thinks about this. Another circle. Bloop. Woo!
That was good.
That's pretty good. So you have another circle. Now we're going to talk about tangential and centripetal accelerations. Your tangential acceleration. Wait. Let's be colorful. Whoop. Your tangential acceleration is going in that direction as it goes around in a circle. Obviously, we're rotating in that direction. Now, you know, wait, hold on. You know, whoop, that your centripetal acceleration is towards the circle, the center of the circle. So, if you just take a look at these diagrams, you should identify the fact that, whoop, your tangential acceleration is always perpendicular to your centripetal acceleration. Okay? To find the total acceleration of the two, a total is equal to the square root of tangential plus centripetal. And this should look familiar. This is the Pythagorean theorem. Because again, you're dealing with vectors here. You're taking your tangential, AT, and then you're adding head to tail, your AC. We're just moving this vector here, this vector here. You have a right angle here, so therefore your total acceleration is going to be the vector sum of those two accelerations. This is exhausting. This is worse than actual class. So, I would ask if you have any questions, but I can't hear you, so I'm not going to answer any. So you have your tangential and centripetal acceleration. You know that those two doodads is, given the Pythagorean theorem, is the sum of this. So if you are going to find the angle for the total acceleration, you're going to have to do, so your tangent is going to be your centripetal acceleration divided by the tangential acceleration. That's how you do it properly. There is another video lesson on physics. Come here, dog. Me, my doggy, my daughters, and my fanny pet. Hi, buddy.